Okay, something very practical that we can do and use when we're working with our numbers, especially really large and really small numbers, is this tool called scientific notation. So a number is written in scientific notation when it can be expressed in this form. We've got a number A times its power of 10. Now, the big thing you got to pay attention to is the value of A. A is always written with one number to the left of the decimal place. Okay, the way to mathematically say that is that the value of A is going to be bigger than or equal to 1 and less than 10. The non-mathy way to say this is you have one non-zero digit to the left of the decimal. If that doesn't quite make sense to you, I think after doing a couple problems, it will. So here's my first example. I'm going to write the number 93 million. That's the number of miles from the Earth to the sun. I'm going to write this in scientific notation. So the first thing I'm going to do is I'm going to look at what is the first non-zero digit. So as I approach the number, I'm floating. The first non-zero digit is 9. Okay, so the number 9 is the first non-zero digit. So I'm going to make the beginning of my scientific notation 9.3. And now what I want to know is how many powers of 10 have I moved the decimal to get from where it was in this beginning number to after the 9. So in this number right here, there is no decimal, so we imply it at the end. And so I'm just going to count the powers of 10. So I go 1, 2, 3, 4, 5, 6, 7. So we got 10 to the 7th. 10 is going to be 7 powers of 10. So please pause the video and go ahead and do this same thing for exercise 1, just to the right. All right, so again, the first non-zero digit is 2, so it's going to be 2.43 times. And how many powers of 10? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 powers of 10. Now notice, when I move my decimal to the left, okay, I'm increasing the powers of 10. We're going up, okay, because that's the decimal places. Now example 2, I'm going to do the same thing with a really, really small number. Okay, so again, first thing, what's the first non-zero digit I come to? So as I go this way, the first one is 6. So it's going to be 6.7 times. And now how many powers of 10? Now notice we are going backwards with our decimal place. So we're going smaller. So that is going to be 1, 2, 3, 4, 5, 6. So that is 10 negative 6 because we're moving in the negative direction on the number line. Okay, do the same thing on exercise 2. So the first non-zero digit I come to is 1. So that's 1.31 times 10 to the, again, we're moving to the right, we're moving smaller decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's negative 9. Anytime you move the decimal to the left, it gets bigger. Anytime you move the decimal to the right, it gets smaller. So here's what I'd like to do. I'd like to write the following number in standard notation. Okay, so we're doing the reverse process on this particular problem. So basically what that means is instead of writing this with a power of 10, I want to decrease this. So we're going to take my 693. I'm not going to have the decimal place. And we are going to move the decimal 7 places. Okay, to write this as just a number. So 7 places is going to be 1, 2, 3, 4, 5, 6, 7. That means I have to add in 1, 2, 3, 4, 5 zeros. So that is going to be 69,300,000. So go ahead and do exercise 3, 4.05 times 10 to the 4th. And I'd like you to write that as a regular number, please. So we've got 4.05 times 10 to the fourth. So I'm going to write the 405, no more decimal. And now I'm going to take that decimal from where it was and I'm going to move it 4 places. So that is going to be 1, 2, 3, 4. Means I have to add on 2 zeros and we have 40,500 is the number in standard notation. Example 4. Now we're going to do the same thing with this. Okay, so I've got 4.75. That's 475. Now this is 10 to the negative 6th. I want to increase this. So I'm going to move the decimal to the left. So we're going to go 1, 2, 3, 4, 5, 6. So that means I'm adding 1, 2, 3, 4, 5 zeros to the front of this. So 1, 2, 3, 4, 5. And so it's 0.0000475. Okay, because now we don't have any power of 10 here. So that means I raised the negative 6. So I had to move the decimal to the left. If you want to raise the exponent, moving to the left raises the exponent, moving to the right decreases or makes it go down. All right, exercise 4, do the 2.3 times 10 to the negative 4. Okay, so this is 10 to the negative 4. So I'm going to take my decimal. I'm going to move it 4 places to the left. So 1, 2, 3, 4. And so that means I have to add on 1, 2, 3 zeros in front of my number. So to get rid of the 10 to the negative 4, we had to increase that exponent from negative 4 up to 0. So we move the decimal to the left. Negative exponents represent small numbers. That's another way to remember that. My final exercise right here for you on this first page is a number that is not quite written in scientific notation. Okay, because scientific notation, the decimal should be after the first digit. So it should be 9 point something. So what I want you to do is I want you to take that number and I want you to do your best to write that in scientific notation. Okay, so in scientific notation, this would be 9.76, and you can put the 0 on. I'm going to leave it off. So now what I've done is I've moved the decimal 1, 2, 3 places to the left. Moving the decimal to the left increases. So instead of 10 to the 6th, it's going to be 10 to the 9th. I increased the decimal by 3. All right, we're going to flip the page. How we're going to end is a nice, useful thing for scientific notation is to be able to quickly multiply and divide very large or very small numbers. So for instance, on my example here, I'm going to multiply 3.4 times 10 to the 9th times 2 times 10 to the negative 4th. So here's what you do. First thing is, since both of these are just all multiplication, this is not distributing. Okay, this is nothing like that. I'm going to multiply the numbers. So 3.4 times 2. And your calculator will tell you that's 6.8. And then 10 to the 9th times 10 to the negative 4th. Property of exponents is when you multiply, you add your exponents. So I've got 10 to the 9 plus negative 4. That is 5. So you go ahead and do exercise 6. Multiply those two numbers. Hey, again, when I multiply the number part out front, 1.3 times 4, that is 5.2. And then 10 to the 8th times 10 to the 6th is 10 to the 8 plus 6 is 10 to the 14th. Okay, lastly, I've got some division here, and we're going to finish up with this. So my last example, I've got 8.4 times 10 to the 17th divided by 4 times 10 to the 5th. So again, we're just going to do what we did before. I'm going to divide the number parts. So 8.4 divided by 4 is 2.1. Then I'm going to divide the tens. And this is just the reverse. When you multiply your tens, you add the exponents. When you divide your tens, you subtract. So 17 minus 5 is 12, 10 to the 12th. So go ahead and do exercise 7. Just be real careful when you when you subtract negatives, that you're doing that carefully. All right, 6.9 divided by 3, that is going to be 2.3. And then 10 to the negative 9th divided by 10 to the negative 5th, that's 10. Now, your calculator can do this, but remember, we're subtracting, so that is negative 9 minus negative 5. Don't forget, we're subtracting two negative numbers. And so that's negative 9 plus 5, that is negative 4. So your last exercise from this section is exercise 8. You're going to multiply those two numbers by first converting them both to scientific notation and then multiply. So push pause on your screen and go ahead and do that problem. All right, so the first number, the 0.00064, the first non-zero number I come to is 6. So that's 6.4 times 10 to the 1, 2, 3, 4. That's negative 4th, since that's a small number and I move the decimal to the right. And then we're going to multiply that times this. The first number is 9.4 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's positive 9 since it's a large number and I move the decimal to the left. And now I'm going to multiply 6.4 times 9.4. So 6.4 times 9.4 is equal to 60.16 times 10 to the negative 4 plus 9 is 5. And I know that looks like scientific notation, but remember this number here can only have one number to the left of the decimal. So I'm going to make that 6.016. And since I moved the decimal once to the left, I'm going to make that decimal, or excuse me, I make that power of 10 bigger. One more power of 10.